Yes, okay. Now we have seen how to define the correlation coefficients and what the difference is between covariance and correlation coefficient. And now we want to look at two examples where we want to calculate these values. To start, let's take this example here. We have here our people with an age, which are these numbers here. We can perhaps call them X. And then we have the corresponding pets that these people have. Let's call that Y. And we want to determine the correlation coefficient for us, age, and pets. And what we need to do is the following. We will quickly write down the formula for the correlation coefficient. That is Rxy is Sy divided by Sx times Psi and exactly. Then let's take a quick look at Sxe. That is the covariance, which was 1 divided by n minus 1, and then the sum of Xi times Y bar. And the first thing we always do when we want to determine correlation coefficients is to calculate the X bar and the Y bar. Let's start with X. Exactly. Or we actually take the red color for this, which is 20, 25, 35, and 30, 40, divided by the number of people, which is 5. And so that is 20, 25, 45, 75, 110, 150, 75, 110, 150, divided by 5. And that is therefore 30th. And now we determine Y bar, which is 1, 3, 1, 0, divided by 5. And that is 1, 5 divided by 5. Exactly. Now we have done the first calculation, and now we determine the covariance, xy, which is 1 divided by 4, so n1. And now let's take a look at the x values and how far they differ from the x in detail. So xi(x), that is x, is 20, and 20 minus 30 is minus 10. Then we take the y term, which is 1, minus 1 equals 0. The next value is 25, so that is minus 5, 3, 1 is in this case minus 2, 2, 3, 1 is plus 2, exactly, Then it continues, 30, that is 0, times something, also again 0. Then we have now 5 and 30, so that is 5 times, minus the first 2001, and then plus 10 times minus the first. And what we see here now, let's take a quick look again, is that we only have negative signs. So we have here 10, okay, 10 times 0 is 0, but then we have here minus 5. Times 2, we have 5 times minus 1, and 10 times minus 1001, which means we have all negative components here. And that adds up to a total of 10, 15, and 25, 15 and minus 25, 1001. Divided by 4, yes, and there we can already see that it is a negative correlation. Exactly. Now we can also determine the standard deviation, so that we can then calculate the correlation coefficient more accurately. We do this So first we calculate Sx. I'll write Sx. Yes, we will calculate the variance, which is 1 divided by 4. And what do we have here now? We have the deviation. We always need to consider the deviation squared from the mean, which is 32,001. We start with 20, person 1, which means the distance is 10, so 10 squared plus. Now we have 25. The distance is 5, so 5 squared. Then we have 30. There is no distance. Then we have again 5 squared, and again 10 squared, so that we have a total of 100, 125, 150, 250, 150, 250 by 4. And then we calculate. Of course, we can simplify now. But I won't do that because I want to show something else. Now, SI squared is again 1,4. And now we have the mean of 0.1. Now let's look at how large the distance is. The distance for person 1 is 0. Then the distance 2 is 2 squared, which is again 0. And then we have 1 squared and 1 squared. So in total we get 4, 5, 6, 4. And what we are going to do now is determine Rxy now. I'll make this brief so that we can separate this from each other. So, Rxy is equal to 25 divided by, and now we have the square root of 254 times the square root of 64. And I already mentioned earlier that we don't want to eliminate the 4, because what we see now is that we have the square root of 4 times the square root of 4, which then becomes 4, and this cancels out with this 4, so that we end up with a value of 25 divided by the square root of 250 times 6. Okay, and now one could of course make various calculations, but I don't want to do that. Even in the exam, that would be completely sufficient for you. I could, naturally, try to simplify this to a 4 or other things, but that's not the point. The correlation coefficient is negative, and you can consider that it is actually greater than -1. So that's the first example of how to calculate such a correlation coefficient in a concrete way. Next, we want to look at an example where there is a very clear relationship between the data x and the data y, namely the following. We see that x is equal to y, or y is equal to x. So if we take a quick look, we see that -4 is 16 squared, -3 is 9 squared, and so on. And if we were to plot this, let's say in black, we would see that these are indeed the points of a parabola, indeed, and there is definitely a connection. We can even calculate y from x, sos, eos, but the question is it positively or negatively correlated? Because, well, on the left side it seems to go down, and on the right side it seems to go up. So that's a bit confusing. And indeed it turns out that the correlation is actually 0. And I want to briefly show you how this can be demonstrated. For this, we first determine x, sos, eos, and you can see that the negatives and positives always balance out, and therefore the whole thing is 0. And I don't want to determine y bar right now because it's a bit more complicated. In any case, we see that y bar will be something positive between 0 and 16. And what we are going to do now is write the formula for the covariances, which is 1 divided by the values. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. so 1 divided by 8. Then we have minus 4 minus 0, which is simply minus 4, times 16y bar plus. Then we have minus 3 times 16, not 1609 of course. Then we have 9 minus y bar, and I will continue like this, skipping a few until we reach 0. Let's take a quick look at that. So 0 times 0 minus y bar. Then I will skip again and only look at the last 2 elements. They are then, because we are here at 3 and at 9, that means we have 3 times 9 minus y bar plus 4 times 16 y bar. And what we see here is that, for example, when we look at 4 times 16y bar, they appear here in the same way, just with an inverted sign. So because the minus 4 on one side and the 4 on the other side keep the 16 the same, but with the same sign, it essentially cancels out here. And exactly the same thing happens with this 3-term expression here. Here we have 3, and here we have minus 3. So these terms can also be cancelled out. And so we see that each term cancels out, and the 0 term here is anyway 0 times anything. So it also drops out, resulting in a total outcome of 0, and thus the correlation coefficient is 0. And that is interesting. Why is that? Because, as mentioned, there is definitely a relationship, but the correlation coefficient, which is sometimes also called the linear correlation coefficient, can only reveal linear relationships and not, for example, quadratic relationships. And that is precisely why it is particularly important that if the correlation coefficient is 0, it does not mean that there cannot be a relationship between the two things. And you can think for yourselves. It's also a practice exercise about what happens when there is a cubic or some other relationship in higher powers, whether that still holds true or if there might even be a positive or negative correlation coefficient.